In this video homework guide, my plan is to continue solving the homework questions from lesson number 4 in the circle geometry chapter, and I will be starting with letter F for this particular video. Alright, so for letter F, I need to find angle 1, and angle 1 is this entire angle right here in green. So the goal is I need to find that particular angle. And in order to kind of start off this problem, I would recommend creating several triangles at the center here. And what I've done there is I created a radius there, so all the radiuses here are equal. So I've created a few more isosceles triangles there. And the key thing here is if I take a look at the center, these blue dots, all these blue dots are going to have the same value in terms of their angle value. So at the center there, I know that it does form 360 degrees, and since there's 5 blue dots, I can divide 360 by 5, which gives me 72 degrees. So I know that each of these angles here, they're going to be 72 degrees each, because I've created 5 triangles that are exactly the same. So I know those angles are 72 degrees. Okay, so after that, you should use the isosceles triangle property here. So that is an isosceles triangle. And so in order to find the two corner angles, I would take 180 degrees minus the 72. So 180 degrees minus 72 is going to be 108. And then after that, I can divide that by 2 and get 54 degrees. So my corner angles here are going to be 54 degrees each. So 54 there and 54 there. Now that's useful because the next thing I'm going to do next is I'm just going to erase some of this now. Be very careful here. Okay, so remember that we have a tangent. Whoops, undo that. Remember we have a tangent line right here in blue, and that tangent line is intersecting with this radius here in orange. So that means this entire angle here is going to be 90 degrees, right? So if I know that entire angle is 90 degrees, and I know part of it is 54 degrees, if I take the difference between 90 and 54, I do get 36 degrees, and that 36 degrees represents this green region, or that green angle there, which is angle number 1. So angle number 1 has a value of 36 degrees. Okay, let's go ahead and find angle number 2 now. Let me just erase this. Okay, so for angle number 2, I think I can get rid of that, and let's just redraw this radius in there. Okay, so for angle number 2, remember these corner angles here, these are 90 degrees, and we know this is we know that this region right here is 72 plus 72, and if these are 90 degrees and this is 90 degrees, basically I have a four-sided shape here. So here's my four-sided shape. And I know that in a four-sided shape it adds up to 360 degrees. So in order to find angle number 2, I take my 360 degrees minus the 290 degrees. So minus 90 minus 90. And at the center there's 72 degrees and 72 degrees. I can minus those two angles. And then that would give me the remaining angles available to find angle number 2. So 360 minus 90 minus 90 minus 72 minus 72 gives me a value of 36 degrees. So angle number 2 is going to be 36 degrees as well. And that's how you complete letter F. Okay, let's move on to the next question here, letter G. Okay, so letter G is a bit difficult here, and I'll try my very best to complete this problem here. So for letter G, I will draw a radius right here connecting to the tangent line. So that gives me a 90-degree box there. And on this side, I will also draw another radius and get my 90-degree box there. And then notice that there's a tangent line right here. So I'm going to draw another radius from my center all the way to that tangent line, and that gives me 90 degrees as well. All right, so basically what I've done there is I've created 4 triangles. I'll try to highlight them. And each of these 4 triangles, just one sec. Each of these 4 triangles, they're exactly the same. So those are four triangles that I'm trying my very best to draw them to scale so that they're exactly the same. And when I do that, then I know these orange angles will also be of equal value there. Okay, so let's just keep that in mind as we are working through this particular problem here. So let's go ahead and complete this problem now. Let me just erase all this now. Okay, so let's take a look at this four-sided shape here. Now in that four-sided shape, we know the corner angles here are 90 and 90, and I also have this 40 degrees. So in a four-sided shape, we know that everything adds to 360 degrees. So let's go ahead and find this big angle right here. In order to do that, I take my 360 degrees minus my two 90s, and then minus my 40 degrees. Let's go ahead and do that. So 360 minus 180 minus 40, that gives me 140 degrees. And then from that 140 degrees, I'm going to divide that by 4 because I have 4 orange circles there. So 140 divided by 4 gives me a value of 35. Okay, so if I go back to my diagram here, that means each of these individual angles are 35 degrees. So 35, 35, 35, and 35. And angle number 1, if you take a look at angle number 1 very closely, angle number 1 is actually these two angles combined. So 35 plus 35 is going to be 70 degrees. So angle number 1 is going to be 70 degrees as my final answer there. Okay, let's move on to letter H now. Okay, so letter H is a little bit easier because here's my radius and here is my tangent line. So we know that's going to be 90 degrees, and this is also going to be 90 degrees. And our goal is I need to find angle P, which is right there. Okay, so for this particular problem, you just want to add up all the interior angles. So my interior angles are 4x, 90, 90, and x. So if I add up all those interior angles together, so 4x plus 90 plus 90 plus x, that's going to equal to 360 degrees. All right, so let's go ahead and solve this now. 4x plus x is going to be 5x. And then if I have 90 plus 90, that's going to be 180. So 5x plus 180 equals to 360. And then I can take this 180 and bring it to the other side, and that's going to be 360 minus 180, which is 180. And then I can divide both sides by 5. And then 180 divided by 5 is going to be 36 degrees. Okay, so so angle P has a value of 36 degrees. And that's my final answer for letter H. Okay, let's move on to question number 3. Let me just zoom out there. All right, so let's do question number 3 next. And for question number 3, we can probably do some quick things right away. This is 90 degrees, that's 90 degrees. Angle 1 is 220 degrees. So here's angle 1, so that means this outside region, that's going to be 220 degrees. And if I know the outside region is 220 degrees, I can find the inside region in blue by doing 360 minus 220. If I do that, I get 140 degrees. So basically this inside is going to be 140 degrees. And then now we can easily find angle 2 because this is very similar to the previous problem. I would just do 360 degrees minus the 290 degrees and then minus 140, and that would be my final answer there. So I believe this question here, the answer here should be 40 degrees here. So angle 2 is 40 degrees. Okay, let's move on to the next one. Okay, let's move on to question number 4 now. And for question number 4, I need to find angle number 1. Okay, so before I do this problem, let's just try to put in some angles that we already know. And I think this angle right here is going to be 90 degrees. That's a common theme for most of these questions. And one more thing that you might want to recognize here is the main shape here, which I'm highlighting on the outside here in different colors. I'm doing this because I want to make sure that you understand that this is a four-sided shape. So that big object there with the different colors, that's a four-sided shape. So what that really means is all the interior angles. So the interior angles are 40, 90, this blue angle right here, and this red angle in the corner. All four of those angles will add up to 360 degrees because all four-sided shapes add up to 360 degrees. Okay, so now that we know that, let's go ahead and let's just see if we can break this down a little bit further. We definitely want to find this inside angle here, that orange angle. And we know the outside angle is 60 degrees. So in order to find that orange angle, you would do 360 minus 160. And that gives you 200. So that orange angle is going to be 200 degrees. And that's going to be useful because now we can find this corner angle there, right? Because once again, in the four-sided shape, the interior angles add up to 360 degrees. So if I know the total value is going to be 360 degrees, I can go ahead and subtract all the individual interior angles I do know. So one is 40 degrees, so let's take it with the 40. Minus the 90 degrees here, and then let's minus the 200. So if I do that, I'll do that on my calculator right here. So minus 40, minus 90, minus 200, that gives me 30 degrees. So this corner angle up here is going to be 30 degrees. Okay, so that's going to be one of the key angles that I do need for this particular problem. And let me just erase all this now. Erase that, and let me just erase this as well. The next thing we're going to do next is we know that this right here is a radius, and this is also a radius right here. So these green lines, that represents the radius. So now if I look at this triangle here, this is a isosceles triangle. So that means that this corner angle has to be 30 degrees. And then we can right away find this angle right here. So that's going to be 180 minus 30 minus 30. Which is 180 minus 60, which is 120 degrees. So this angle right here is 120 degrees. And after that, we can definitely find angle number 1 now. Let me just erase that 200 there, because angle 1, we can definitely find angle 1 because we know that this entire angle here adds up to 360 degrees. So I know part of that is going to be 160 and then minus the 120. And that should give me angle number 1. So 360 minus 160 minus 120 gives me a value of 80 degrees. So 80 degrees is the answer for angle 1 for that particular problem. Okay, let's keep on moving along here. I'm going to skip these questions. These aren't super important. Let's go on to question number 7, and then we'll finish off with question number 8 and 13. Okay, so for question number 7, what we're going to do here is we're going to put a dot in the middle, which represents the center. And then I am going to draw a radius right here. And then I'm also going to draw another radius right there. So that represents 90 degrees, and that also represents 90 degrees. And what I'm going to do next here, this is the tricky part here, I'm going to draw another radius right down there. And what I've done there is I have created this isosceles triangle there, and I also know that in the upper corner here, this whole thing adds up to 90 degrees. So if I do 90 minus the 58 degrees, 90 minus 58 will be 32 degrees. So that means that this angle here is 32. Okay, so if I take this 32 and that 58, that adds up to 90 degrees. Okay, so let me just put the 32 there. If that's 32, this will be 32, and then I can find the central angle. So I'll do 180 minus 32, and that gives me 116 degrees. So that right there is going to be 116 degrees. And then what I'll do next is I'm just going to extend this line here all the way down there. And then you'll see that now I have angles on a line right here. So that adds up to 180. So 180 minus 116 is going to be 64. So this is 64 degrees right there. Okay, and as you can see, this triangle right here, we have 2 out of the 3 angles. We have 90 and 64, so I can definitely find that third angle right there by doing 180 minus 90 minus 64. So 180 minus 90 minus 64 is going to be 26 degrees. So that's going to be 26 degrees. And because we're going to assume that this is symmetric, I mean, that's going to be 26 degrees as well. And so 26 plus 26 is going to be 52 degrees there. So angle number 1 is going to be 52 degrees. Okay, let's move on to question number 8. And for question number 8, I need to find angle number 1, which is at the very bottom here. So let's go ahead and draw a radius there. And if I draw a radius there, I know this is going to be 90 degrees. And I know that this is a radius, and that's a radius as well. But I can definitely find this red angle right there, because in my triangle here, we know this triangle adds up to 180. So 180 minus the 90 minus the 40, that's going to be 50 degrees. So this right here is going to be 50 degrees. And then after that, let me get rid of the blue colors there. And I know that this is going to be angles on a line. So angles on a line add up to 180 degrees. So this has to be 130. So 130 plus 50 is 180. And then we know that these two corner angles, I mean, this has to be 25 now, and this has to be 25 degrees. Because if I look at this whole triangle now, that's an isosceles triangle there. And we want to make sure the two corner angles are the same so that it adds up to 180 degrees. So my final answer here is going to be 25 degrees for angle 1. Okay, let's keep on going on. So 2 more questions to go, and then we're done the homework questions. Question 13 and 14. Okay, so this one's kind of a long one here. I know angle 4 is going to be 65 degrees. So let's put the 65 degrees right there. And now we need to break this down. Okay. We've got to find angle number 5, which is up in the corner there. So we're going to find angle number 5 over there. Okay, so in order to kind of start this problem off, I would draw this or highlight this radius right here. And I would also highlight this tangent line here in orange. So that means this is going to be 90 degrees right there. Just 1 second, 90 degrees. Okay. So we know angle 3 right there is going to be 90 degrees. Okay, so the key part now is we've got to find angle 2 here. And we do have an isosceles triangle there. Let's keep that in mind. But let me just kind of erase some of the colors here, and let's just see if we can make a little connection now. Okay, so we know what I'm trying to emphasize right now is this red part right now, that's angles on a line, right? So we know angle 4 was going to be 65 degrees, that's given to us, and we also found that angle 3 was 90 degrees. So now we can find angle 2 because we know angles on a line, that adds up to 180 degrees. So 180 minus 90 minus 65, that's going to be 25 degrees, I believe. So that's 25 degrees. Okay, so let me just erase this again. So this is going to be 25 degrees. That's 90, and that's 65. And remember, this is a isosceles triangle here, so that means this corner angle has to be 25 degrees as well. And then 25 plus 25 is 50, so this angle has to be 130 degrees. And then once again, if I get rid of that color there, we do have angles on a line here, so this has to be 50 degrees. So 50 plus 130 is 180. And then if I take a look at these angles, the 90 and the 50, that means this angle here should be 40 degrees, so that adds up to 180. And so since this is 90 degrees right here, this has to be 50. And then finally, I can take a look at this triangle here in blue. I have 2 out of 3 angles. I can find the 5th angle there by doing 180 minus 65 minus 50. So 180 minus 65 minus 50 is going to be 65 degrees. So angle number 5 here is 65 degrees. Okay, let's move on to the very last question here, question number 14. For that. Okay, let's move on to question number 14 now. And for question number 14, I know that side AB is perpendicular to side BC. So here is side AB, and here is side BC, and they're perpendicular because of that 90-degree box right there. And I know that AD has a value of 6. So let me just erase this now. I know from here to here, that is a value of 6. And over here, I know BF is equal to 2. So from here to here, that has a value of 2. And I need to find the value of AC. AC is basically this length right there. Okay, so let's go ahead and start breaking this problem down. And this is where I might have a little bit, some problems with this question here, because I need to draw a center spot right there, which may not be, sorry, that's not quite center, but I think drawing these diagrams to scale is sometimes a bit of a challenge. Okay, so what I'm going to do there is I'm going to draw a radius straight down, and then there's a radius straight here. So I have a square there because these are all 90 degrees. And so basically what that means is if this is 2, then that right there is also going to be 2 as well, because the radius here is the same distance. Okay, so that's part 1 of the problem there, is labeling the side there is 2. I'll just erase that. Okay, so redraw that, redraw that. Okay, so basically this whole length right here is now going to be 8. Okay, so the next part of this problem now is I'm going to draw another radius right here. And I will create a 90-degree box there and a 90-degree box there. This is 90 degrees as well. Okay, so the next part here, because I have a radius here and a radius there, they're equal. Basically what the next part of the theorem is that these two green lengths, they're also going to be of equal value, because they're both, that's part of the tangent line property there, so this is going to be 6 right there. Okay, and if I use my yellow marker here, these two lengths here are using the same theory, because they're both coming from the radiuses here. This distance here is also going to be the same as this distance right here, which is x. Okay, so one thing that I need to do now is let's go ahead and just recreate this triangle here. I have this big triangle here. I've established that this side is going to be 8. And if I take a look at this part here, this purple, that's 6, and this x, if I add that together, that means this is going to be 6 plus x. And then if I take a look at this x, this x down here, and that 2 there, x plus 2 is going to be the bottom length, so this is going to be x plus 2. And then remember, we also have this perpendicular box right here, right? So there's a perpendicular box right there. Okay, so here's the triangle that I've kind of done on the side there, and let's go ahead and find the value of x now. Because if I have the value of x, then I can definitely find this hypotenuse here, which is what the question is asking us to do. So we basically have to use the Pythagorean theorem here. So x plus 2 is one of the legs. So x plus 2 squared plus the other leg, which is 8. So 8 squared equals to the hypotenuse, which is 6 plus x all squared. And now I just need to solve this big algebra problem here, and then the question will be completed. 8 squared is going to be 64, and then I can expand that, 6 plus x times 6 plus x. And then from here we just use our FOIL techniques. So x times x is x squared, that's going to be plus 2x, 2 times x is 2x, and 2 times 2 is 4, plus the 64. And then I can do some more FOIL over here. So 6 times 6 is going to be 36, plus 6 times x is 6x, and then the inside, that's another 6x, and then x times x is x squared. Okay, so now we need to solve this equation here. I know for a fact that this x squared and that x squared will cancel off, and if I add 2x plus 2x, that's going to be 4x plus, and then if I add 6 plus 64, that's going to be 68. Equals to, 36 remains, plus, and then 6x plus 6x, that's going to be 12x. Okay, Okay, and then after that, let's go ahead and move this to the other side. And then after that, we will take this 36 and move that to the other side. All right, so now I have 12x over here minus the 4x, and then I have 68 minus the 36. And now we're almost done here. This is going to be 8x. And 68 minus 36 is going to be roughly it's going to be 32. And then I can divide both sides of the equation by 8. And that means x equals to 4. Okay, so let's go ahead and solve the problem now. Let's go back to the original diagram here. Let me just erase a lot of this. Okay, so the goal was we need to find AC, right? Which is this length right here. We did mention already that this length right here was the same length as that length there. So if that's 6, this has to be 6. And we know that this x here, that's x. So 6, and we did figure out that x was 4. So 6 plus 4 is going to be 10 as my final answer.